All right, so we're going to try to figure out this problem where Eugene is making quarterly contributions of $500 into an account paying 6% for 35 payments, but then the bank changes the rate and he makes some more contributions. Whenever we have a problem like this where the rate changes or what we're doing changes, we have to think of it sort of as a separate chunk of money or separate sort of phase. So in this case, we're going to sort of think of it in a few parts. First off, for that first 35 payments, right? So that for that first chunk of time, he's putting in $500 at 6% rate for 35 payments. Notice it's not 35 quarters, but 35 not 35 years, but 35 payments. We'll figure that out later. Now, at the end of that time, the rate changes, right? So this we're going to think of as one sort of phase of the calculation. Now, when the rate changes, what's going to happen to the money that's already there? Well, the money that's already there is going to continue to grow, right? But that money's sort of already there. We can't use the same like savings annuity formula calculation that we're using over here for the rest of the contributions because the rates change. So we're going to sort of have to think of this as that money now just grows, right? Grows at 4% for 30 quarters, right? The equivalent time of 30 more contributions. Meanwhile, while that chunk of money is just sitting there growing, we have a new chunk of money starting at the same time, right? Because he's making additional $500 payments now at the 4% rate for the 30 quarters, right? So we got sort of three phases or chunks of money going on. So let's see if we can figure these out. So I'm going to pull up a calculator here. And our first chunk of money is, again, $500 contributions at 6% for 35 payments. Now this chunk here is a savings, pardon my horrible handwriting here, a savings annuity, right? So that one we're going to put into our savings annuity formula, where the individual contributions or payments are $500. We've got our what do we got? We got our 1 plus, no, yeah, so we got our 1 plus interest rate was 6%, so 0.06 compounded quarterly. Now, in our formula, normally we'd put KT, right? So number of compounds per year times number of years, right? So normally we have, we'll come back to this here, right? Normally we have 1 plus R over K to the KT in the formula. And again, if it was quarterly, let's say quarterly is 4, right? And let's say if it was for 5 years, then we'd have 4 times 5 is 20. And what is that 20? It's 20 quarters, right? 5 years, 4 quarters in a year is 20 quarters. So this together, the K and the T together, is the number of quarters. So in this case, when we use our calculator, instead of putting 4 times some number of years up here, we can just put in, hey, it's happening for 35 quarters, right? And then our minus 1 and our R over 4 there. And there we go. That gives us, in our first calculation, how much money we have at the end of that first 35 payment period of time, right? So we've got 22,796, and so at this point in time, right here, we have $22,796 already in the account. Now remember, that amount of money is now going to grow at 4% for the next 30 quarters. This is just plain old, right? Growing is just plain old compound interest. Compound interest, right? So now we're going to use this amount the $22,796 as the starting amount for compound interest. So let's do that. So pulling up my calculator, we're going to use that 22,796.04, and we're just going to do compound interest. So 1 plus R over 4, or R over K. Again, we're still quarterly, so our K is still 4. Our new interest rate is now 4%. And in our exponent, again, normally we'd have KT, compounds per year times number of years. But again, together, those make up number of quarters. And remember that second growing period is now 30 quarters, right? So that first chunk of money, we built up $22,796, and then we let it sit earning interest for another 30 quarters, and now we've got $30,725. So we got $30,725 and some number of cents. What was it? 62 cents? 62 cents. And that's how much money this original set of contributions have now grown to over those additional 30 quarters. Now we have to consider this chunk, these additional contributions. And this is, again, just a normal set of contributions into a savings annuity. Right? This is just another savings annuity. The only difference between this savings annuity and the last one is that our interest rate has changed and our number of quarters has changed. Right? So we'll set this up just like we did the one before. We'll do 1 plus 0. Again, my interest rate is now 4%. Again, my exponent is going to be the number of quarters, since we're given that instead of years. And we got the 0.04 over 4. And there we go. So after those 30 quarters, this chunk of money has grown to $17,392 and some change. Now, how much is his final balance? Well, his final balance is a combination of the amount that we accumulated from the original payments, contributions, and the amount we've accumulated here. So in my calculator, I could say my final balance is going to be the $30,725.62 plus the $17,392.45 that I had built up from my second set of contributions. And my final answer for this problem is $48,118.07 is the final balance in the account.